Hi everyone, we continue assembling our skid steer loader. The expansion tank will serve as a hydraulic tank. Its volume is 20 liters. This should be enough for the entire system. There will be 6 coupling fittings in it. 2 of them are for the supply, 2 for the pushback, and another couple for the drainage of hydraulic motors. The coupling fittings will be welded to the tank. I also got an engine from the past projects. Hope its power will be enough for 2 hydraulic pumps. Still, it has no electric starter motor, but if the tests are successful, it's not that difficult to install it. For checking purposes, I'll install one gear pump with a volume of 16 cubic meters through the adapter. I'm gonna put the motor right here for now. I'll also weld a mast for the hydraulic tank temporarily. There certainly must be drain in the hydraulic tank, as the oil had to be drained a plenty of time. I'm gonna put the distribution valve in this place for the right hand. All the components are in their place. Now they need to be connected with high-pressure hoses. The oil is supplied from the hydraulic tank into the pump. Then the oil under pressure gets into the distribution valve. In my case, it's 2-section. In case there's no consuming, the oil drains again into the hydraulic tank through the return pipe. It's also necessary to put an oil filter in front of the pump. Then I connected the hydraulic motors to the distribution valve. Also using an ordinary hose, I connected the drainage to the motors. We can fill the oil in and start the engine. The right lever is responsible for the right side, and the left lever replies for left side. Of course, it's desirable to control the course of the loader with just one distribution valve, but in this case it'll work like a car differential. Which engine is easier to spin, that one's gonna do it, and it's necessary for the skid steer loader. The 2 sides could work independently from each other. Also, the GP16 pump with its 30 liters won't be enough for 2 motors. But even in this case, the mechanics works, and it's very good. Now I want to try to install a joystick on the distribution valve. It can be controlled by one lever. Many craftsmen make it homemade, but I chose the production version. It jammed at the beginning, but after some lubrication began to work smoothly. One section replies for the right and left direction, and the second one for the front and back direction. For activation of the both at once, you need to move the lever diagonally. It's also possible to measure out and open the valves gradually irrespective of each other. Okay, I figured out the mechanics. Now we need to install another hydraulic pump. For this purpose, I'm gonna make a drive with a reduction gear for 2 hydraulic pumps. I'll need 2 drives for the gear pump and a platform on which everything will be attached. I made it from 6mm slab, as there was no single piece. I'll need a sprocket with the coupling on the motor shaft, 2 sprockets for the drive of GP16 and a chain with a suitable pitch. Globally speaking, it's 1 to 2. First I'll make the back plate. I made a stencil of the future attachment on the motor and cut the holes in the slab. I welded the second plate. There'll be the gear pump drives on it. There is no other way to install the drives, the sprockets will interfere with their attachment to the slab. I'm gonna weld the sprockets as well as on the drive shafts. In order not to weaken the platform, I screwed a metal strip to it. Now we need to make a box from 2 mounting platforms. The platform on which the gear pump drive is located turns into a cover. It'll be attached with the bolts. There'll be no tensioner. I fitted the chain immediately so that it got stretched. Later, when it stretches, a chain damper can be installed. Now we can check the whole mechanism work with the started engine. After that checking, I welded the missing sidewalls to the box. The reduction drive is ready. I painted it at once and welded another fixing bolt on center. I made a test reaching peak of 5,000 revolutions per minute. Now the RPM governor is removed. Everything remained intact. I connected the governor back and measured the RPM on the gear pump drives. As a result, I got the passport degree. The engine made about 3,600 revolutions. The drive reduces them by half. The geared motor will be mounted on the channel that's gonna be welded this way. Then I put the gear pump in its place and connected it to the system. I put a temporary chair on the frame. Wanna drive the car from the inside. Now the engine idles and even the speed decreases the reduction drive. It feels like the hydraulic motors lack the oil flow, but that's not the main thing. The main thing is that the reduction drive is working. I have a little left to do. I have to install the second distribution valve and one more pump. I took exactly the same distribution valve in order the oil flows were distributed equally. I drained the oil and connected another feed to the hydraulic tank. I also put another filter on it. There'll be two independent circuits. Almost everyone sets one supply on two gear pumps. I think this is absolutely wrong, as two hydraulic pumps may not have enough oil flow from just one sleeve. The filter also loses its throughput capacity with time. The distribution valve connects just like the first one. The only thing, I'm gonna cap off the unused section in order not to spill the oil. I took the pump of another company, but its characteristics are completely the same. There was no angle flange, so I had to put a straight one at the pump exit. The difference is only in the massiveness of the rear wall. Now the supply of the hydraulic tank will be in front and the pushback at the back. Then I shifted the left high-pressure hoses of the left motor to the left distribution valve. I also put the plugs and changed its position. We can pour the oil again and test the cart. Now that each motor has enough flow, the motion became much faster. By the way, these Bulgarian distribution valves of increased smoothness are exactly what is needed for a hydraulic machine. Also, the hydraulic drive works at partial execution mode at such speeds, and the engine expends less of its resource. The buggy on tracks also rolled easily on the doll, but it wasn't able to even turn around in the snow. So it's about time to check the entire assembly outside. I left the same spinach of the engine. This means the hydraulic pump valve makes now about 1000 revolutions. Everything works at low speeds, now we need to increase them. It became much faster. There are also 1000 turnovers in reserve. If we remove the RPM governor, for example, it'll be possible to press full gas for a short time to travel from point A to point B and move much faster. For this purpose, we can install the gas pedal under the right foot. Still, even without it, the motion turned out to be sufficient. The parasitic power is more important than the speed of the skid steer in my thinking. In case I'd have twisted a bit longer, I could have broken off the coupling fitting of the left hydraulic pump. As it fell out, it cannot feel the snow at all. Now I want to try to ride on some soft dry ground. I have such suitable place under the shelter. The hydraulic motors easily turn the wheels through the gear reduction rate 1 to 3, and the engine copes with 2 GP16. Even the RPM governor is not activated. I guess the test passed successfully, and this is the most important thing. Now it's possible to assemble the skid steer loader on this platform. Thanks everyone for your attention. In order not to miss the release of new episodes, be sure to subscribe to the channel. Also, if you liked the video and the material was helpful, you can like it and leave a comment. See you in the next part.